calculator, the easiest way to do these is just to plug them in the calculator and to look at them. They're all quadratics, so the domain of them is going to be negative infinity to positive infinity, but let's just plug them in and look. I don't have my other calculator here, my Inspire, but it's the same idea. I'm just going to type in x squared minus 4x plus 4. And then I'm going to hit graph. Reset my window, but I was here from calculator. So let's see. All right. So this is what my quadratic looks like, and so it looks like it has a domain of negative infinity to positive infinity if you're writing it in interval notation. If you're writing it in algebraic notation, then it's going to be all real numbers, a set of all real numbers. Your range, in this case, you can see it touches right here. So if I go to my table, I can see that it looks like it's, 2, 0 is where it touches 0. But it actually touches there, which means that that's a bracket. So it would be bracket 0 to infinity because the arrowheads are up here. So it's going to go up forever. Or that would be written as y is greater than. All right, so let's look at, so that was number 11. So let's look at 12. So 12 is just negative x squared plus 3x. Now I can tell you by looking at it, it's going to be upside down. It's going to be going down because it's negative x squared. But let's go ahead and look at it. Look at it in case it's been shifted up or something. So looks like that, and it has been. So it's upside down. So still you're dealing with domain of negative infinity to positive infinity, or all real numbers. And then this point right here is at the point, looks like 3, but we can check our table just to be sure. Or I can do a maximum. Looks like at the ordered pair, oh, maybe 2.5. That looks like it's a 3. But I can do a second trace. It's a little bit different on the Inspire. I think it's under menu, and you want to do, in this case, a maximum. So I'm going to hit 4, and it tells me to go to the left. Now this is actually really nice on the Inspire calculator because you can just slide the pieces over. On this one, I have to arrow to the left and hit enter, and then arrow all the way across to the right and hit enter. And it gives me my maximum value of 2.25. So in this case, my range goes from negative infinity to 2.25 with a bracket because it goes down. So always when you list range, you go the lowest point first. And this thing goes down to infinity forever. So it's going to go from negative infinity up to that peak, which is at 2.25. If you are unsure on how to find it on your calculator, how to find a maximum or a minimum on your calculator, you could probably YouTube that real quick and find it, no problem. So let's look at number 13. So this one again is going to be right side up because it's not negative. It's going to be x squared minus 2x minus 3. And hit graph. All right, so again, I have this minimum point down here. I'm not real sure what it is. So I'm going to do a second trace. And I'm looking this time for a minimum value because it's the lowest value. My calculator says left bound, which means I need to go to the left of the minimum I'm looking for and hit enter. And then mine chooses to right down, so I arrow across to the right and hit enter, and enter again. And down here at the bottom, it's going to tell me my minimum value, which anytime it gives you this 0.9999999, that really is 1. So it's the ordered pair 1, negative 4, which means that, of course, my domain that we were talking about again goes negative infinity to positive infinity. And my range this time goes from that negative 4 up forever. So the lowest value is negative 4, so I put that first, and then forever up. Or if I were doing it in algebraic, that would be y is greater than or equal to negative 4. All right. Then the next one. All right, so we have another upside down one. So this is negative x. So this one's going to have a max point, a maximum, because it's upside down. And I know that because of the negative in front of the x squared. And that makes it a reflection. So it's flipped over. So So I'm going to be looking for a max. Oh, this one's easy. It looks like my max goes right through 2. If I go to my table where x is 0, yeah, y is 2. So my domain is negative infinity to positive infinity again. And this time my range, remember you always start with the smallest value. So it goes down forever to negative infinity. And then the highest point of this thing is at 2. And so that's a bracket. Okay? So moving on to 15. All right, a toy rocket is launched with an upward velocity of 32 feet per second. The equation h equals negative 16t squared plus 32t gives the height of the ball t seconds after it is launched. First, we're going to determine whether the function has a maximum or a minimum value. Well, in this case, it's going to have a maximum, and I know that because of this right here. The thing in front of the t squared is negative, which means this is reflected. It's an upside down parabola. So it has a maximum. And they want us to state the maximum value, so I'm going to plug it into y equals. So negative 16x squared. The calculator won't do t's. It doesn't understand. Even though you have a keyboard and it can do, you can type letters and stuff, it doesn't understand in this mode what t and stuff means. It only understands x and y. So I hit graph. Now there's a good possibility it's not going to show in my window. Oh, it does. But let me look at my negative. That's really shocking. Let me look and see real quick there. There's 16t squared plus 32t. Negative 16 squared. Oh, well that explains that. It's after 3. 32. Oh, there we go. That'll be better. All right. So that's what I was thinking. There's a good possibility it's not going to fit in the window. So I'm going to adjust my window. I don't need this. This is talking about an actual item, and t is, or my x value in this case is t. It's time. Time is never negative. So I don't need 0. I mean, I don't need the negative values of x. It doesn't usually take these projectile motions long to hit the ground, but I can increase that a little bit if I want to. And still scale by ones. Now my y value, again, we're shooting a rocket from land, and it's going up in the air, so I don't need negative values, not this time. Sometimes we're going into water, in which case we would. We don't need it this time. And I could see when I first grabbed it, it went off my screen. So I need bigger numbers here, so let's go up to 25 and see if that's enough. Absolutely. And my x values, I don't need near as many x values as I got. So I'm going to adjust my window again for less x values. And the only reason I'm doing that is because it makes the graph a little easier to look at. All right. So now there's my max point right there. So I'm just going to do a second trace and find my maximum. So I'm going to go to the left. And if you can't see your cursor on the screen, which I can't, right here it tells you down in the corner of this calculator where your cursor is. So I'm just going to keep arrowing until I see it. It should come up on my curve. There it is. All right, I'm going to go to the left of the peak and hit enter, to the right of the peak and hit enter again, and hit enter one more time. And it gives me a maximum value of 116. So my maximum, so that's the ordered pair. So let's look at the way the question is worded, because the way it's worded will determine how you need to answer. It says state the maximum or minimum value. The max value is 16. It occurs at t equals 1 second. So at 1 second, the maximum value is 16. Then C, state a reasonable domain and range for this solution. Well, my domain, if you look, let's go look at our table and see if we can see. All right, so at 0, 0 is where this thing started. We shot the rocket off at 0 seconds. And then look right there at 3 seconds, it's already at negative 48, which means it's already gone below the ground. If we look back at our graph, so I went from 0 to 6, so this is 1, 2, 3, 4, 5, 6. So really all we need for our domain is 0 to 2. So domain is 0 is included, that's when we start, and 2 is when the thing hits the ground. So, and my range is from 0, where we shot it off, to 16, which is the highest peak. So that is a reasonable domain range. Honestly, I don't know what your teacher will accept, but I would accept anything in there, like 0 to 5, I would take that, because it's okay to see, like, it hit the ground at 2, and then there's time after that. As far as range also, I would accept like 0 to 20, because we're talking about something reasonable, not exact. So, but I don't know how your teacher feels about that. So, all right, so let's go on to 15. All right, so this is solving each equation by graphing. And then it says if we can't find integral roots, what that means is if you can't find exact numbers to round to your decimals. So again, we're going to be putting this stuff in our calculator. So let's go to y equals, and I'm going to put in x squared minus 3x minus 4, and hit graph. Ooh, I need my graph to go back to my regular window. So I'm going to hit zoom 6, that zoom standard, and hit my standard window. All right, your solutions are where the parabola crosses the x-axis. So these two values right here are what I'm actually looking for. Now there's several different ways you can find them. If they are exact values, you can go to the table and look there. And anywhere y is 0, so this one's easy, because right there at -1, y is 0. And then again down here at 4. So those are my solutions. X equals -1 and x equals 4. So that's the easy way. If they show, if you can look at them straight on the graph and you can see they cross actually on a grid line, you should be able to go to the table and get them. I'm sure we'll have one here in a second where we're not able to do that, so let's just keep going. Let's see, negative x squared plus 6x minus 9, and hit graph. All right, now it looks like this time it only touches once. That would be what's called a double root, because it just touches and turns right back around. And it looks to me like it's at 3, but let's go to the table and check. So, yeah, right there, where x is 3, you see that? Y is 0, so that's the solution there. There's only one solution on that one, because it bounced, that's what we call it. So, while parabolas most of the time have 2 solutions, if they bounce like that, they'll just have 1. All right, let's go back and type in our next one. So we've got x squared minus x minus 12 graph. All right, it looks again like I can see these. It looks like it's going to be -3 and maybe 4. So I'm going to my table, -3 and 4. All right, so 19. Got x squared plus 4x. -3. Square plus 4x minus 3, the graph. All right, now these don't look so straightforward. They kind of look like they might be fractions. So I'm going to go ahead and do a second trace, and this time when you're looking for x-intercepts, their other name for them is zeros. So I'm trying to find zeros. So whatever calculator you're using, if you're not sure how to find zeros, just Google or go to YouTube and put zeros on a whatever calculator. So there are 2 of them. So I got to tell my calculator which one I'm looking at. So I'm going to arrow all the way to the left and hit enter, and then to the right and hit enter again, and hit enter again. And so I get -4.64, and it says in the instructions to round to the nearest tenth, I think is what it says? Yeah, nearest tenth. So this would be x equals -4.6. Now that's just one of them, because I have another one right over here. So I'm going to do a second trace again, and look for that intersect. I'm going to arrow all the way over. Now it says to go to, oh wait, second, I'm not doing the intersect, I'm sorry, I'm doing the 0. Left of it, left also happens to be underneath. So hit enter, and right, enter, and enter. And this time it's 0.6. X equals 0.6. It's the positive 0. All right, and let's look at number 20. All right, so before I do anything on number 20, I want to put this in my calculator. I need to rearrange it. So I'm going to move the -21 over. So I have x squared minus 10x equals -21. So I need it all on one side. that negative 21 and move it to the other side. So now I have x squared minus 10x plus 21. And that equals 0, or that equals y. So I can plug it in. So x squared plus 10x plus 21. And the graph. All right, looks like I've got some exact values again. It looks like negative 3 and negative 7. So I'm going to my table. There's negative 3 and negative 7. So x equals negative 3 and x equals negative 7. And number 21 is 6x squared minus 13x. Okay, 21. Let's get back to my brain. It's a little harder to see. So 6x squared minus 13x equals 15. All right, so again, you have to move that 15 to the other side. So I'm going to subtract 15 from both sides. And that's going to give me 6x squared minus 13x minus 15 equals 0, which is where I can put my y, which means I can plug this into y equals right there. So 6x squared minus 13x minus 15. And hit graph. All right, so this one looks like it's a little bit off, and that one looks like 3. But let's go to our table and see. Yeah, that's what I thought. So 3 is definitely one of them. X equals 3. But the other one must be a fraction of some kind, or decimal. So let's go back to the graph. And it's this one over here on the left that I can't really tell. So I'm looking for, remember, x-intercepts are the same thing as zeros. So I'm looking for a 0. I'm going to arrow to the left of that value. There's my cursor. All right, so there it is. To the left, it also happens to be above. I'm going to hit enter. And to the right of it, which also happens to be below, and I get negative 0.8333. Oh, it said to the nearest 10, so sorry, that's just negative 0.8. All right, and then let's see, are there any more in that little section? Yeah, 22. Find two numbers that have a sum of 2 and a product of 15. Do we really have to do that? I'm not going to do that. I mean, I could do it, but I don't think that will help you. So I'm going to skip 22. All right, so let's go on to, let's see, 23. All right, this time we are, describe how the graph of each function is related. Okay, so this is our transformations that we were talking about. So remember, if it is outside of the function, so there's not a house or anything, no parentheses, nothing that groups it with x, then it's a vertical change. So on number 23, f of x equals x squared plus 8. So we're relating all of these to our quadratic. So anything that looks different than the original. So here's your original. F of x equals x squared. All right, well, if you look at 23, it has one obvious difference, and that's a plus 8. That plus 8 is not grouped with x in any way. It's just kind of hanging out on the outside, which means it's a vertical change. It is, and y don't lie, so that means it does exactly what it says it's going to do. It vertically is adding 8. And if we vertically add 8, that means we're going up 8. All right, so the next one, f of x equals, let's see what the next one says, x squared minus 3. All right, so anything that looks different than the original. So everything is the same until this minus 3. So again, it's not grouped in any way with x, which means it's a vertical change. Minus 3 does exactly what it sounds like it's going to do. It's going to go down 3. 25 f of x equals 2x squared. All right, well, only thing that looks different is that this one doesn't have a 2 in front. So it's this piece. So that's 2 times x squared. So anytime you have 2 times something, that's making it bigger. And it's a vertical change. So it's 2 times taller. It's vertically 2 times bigger. So this is what we call a vertical stretch by 2. Everything is going to be twice as tall as it was before. Okay, 26. We've got 2 things going on in 26. We've got 2 transformations. So if you look at 26, I have 2 things different than the original. I have a 4 in front and a minus 18. So the 4 in front is making it 4 times taller than it was before. So this is vertical stretch by 4. And this minus 18 is moving it down 18. 27. Okay, we're looking for anything that looks different than the original. So I have a 1/3 in front of my x squared. It's not grouped with x in any way. So that 1/3 is making, it's 1/3 times the original function. Anytime we multiply something by a fraction, like if I multiply your height by half, it would make your height half of what it was, smaller. So multiplying by 1/3 is what we call a vertical compression, or they may use the word shrink. So whatever your teacher calls it, compression or shrink, they're both correct. It's just different ways of saying the same thing. And it's by 1/3. All of your vertical values would be 1/3 of what they were to start with. If you had a table of data values, you would take all of your y values and multiply them by 1/3. 28 is f of x equals 1/4 x squared. So again, the only thing different than the original function is that 1/4, which again is a vertical compression. Vertical compression by 1/4. And these, when you see these, what they're going to do to the parabola, they're going to make the fraction look fatter. But if you think about that, it makes perfect sense. If I take something and I compress it vertically, I squish the top and the bottom, it's going to make it, when you think about it, if I squished you down, pushed on your head, and you would still weighed the same, everything would go out the sides, you know, it would get wider. So it's going to look fatter if you vertically compress something. All right, write an equation for the function shown in the graph. Okay, so there's a couple of things. In order to look at this, we need to know exactly what the parent function looks like. So let me get a little graph here. So I'm going to zoom in a little bit. The original parent function of the parabola has a dot at 0, 0, and then it's over 1 up 1, left 1 up 1, and then it's over 2 up 4, and left 2 up 4. That's because you're squaring those values. So it would look like this. Now, if you look at what they gave you, it's been shifted down. That's pretty obvious. But we need to look at what's changed about the vertex. Besides the fact that it's been shifted down, I'm going to put the graph on here of what they did so you can see. So it's down at 1, 2. Looks like it's down at 3. So that's the vertex now. It's at 3. But if you look, it doesn't go up 1 over 1. It's not crossing at a grid line right there. It's going over 1 up 2 before it crosses, and left 1 up 2. And then from the vertex again, if you go over 2, instead of going up 4, it's going up 8. So it's going to run into my other one, but it's over 2 up 8. So it looks like this, which means, if you think about that, this first one went over 1 up 1. This one's going over 1 up 2. This one went over 2 up 4. This one's going over 2 up 8. All of my vertical values have been doubled. So this one is stretched by 2 and moved down 3. So if we're going to write the equation for this one, the equation would be f of x. So remember, this is the original. F of x equals x squared. Now I have to show that it is now stretched by 2. That'd be a 2 in front. And moved down 3. So it'd be 2x squared minus 3. All right, number 30. A ball is dropped off a cliff that is 100 feet high. They give us the function h equals negative 16 t squared minus 100. Oh, plus 100, sorry, to model the height. Compare the graph of this function to the graph of h of t. All right, so let's look at it. So if and I can actually put them both in my calculator if I want to look at it at the same time. Negative 16x squared plus 100. And if I hit graph, they want me to compare that to the graph of just h of t squared or the parent function, basically. All right, so it doesn't show on my window, so I'm going to adjust my window real quick. I think that, I know I need to go up quite a bit higher. It goes to 100 feet, so let's start at 110. See if I can see the top if I do that. Yeah, there we go. All right, so this is still the origin down here. So the original would have been right here. So let's look at the original one so you can see it. It would be x squared. All right, so there's several things about this that are different. Number 1, it is much narrower than the original. The original is the big fat one. It is upside down, and it has been shifted up. So in that case, the narrower comes from the vertical stretch. So, and that's for the same reason that we talked about vertical compression. If I were to take you and stretch you up by the neck until you were 16 times taller than what you are right now, you would definitely be much thinner. So that's why it's so thin, is because it's been vertically stretched by 16. So it's reflected. That's why it's upside down. Stretched. And shifted up 100. So that's what makes it look so different. All right, I'm going to stop this video for right now because I don't want to put so much on one video that it's like a drag to watch all of it. So I'm going to stop right there at 30, and then I'll do the rest of them on a separate video.